Hey guys, welcome. My name is Kyle Norman and I'm with MLC Manufacturing Services. Today I want to talk about a question that I get asked a lot. Hey, I already have a 3D printer. I've got a desktop FDM printer. Why do I need 3D print services? That's a fair question. So what we're going to highlight today is what you can and can't do with that FDM machine and where industrial machines pick up the slack from that machine. Those machines have a great use. We're never going to tell you not to use those machines. They are fantastic for your application, but they have a limitation. So today we're going to talk about the industrial services that we offer here at MLC Manufacturing Services that can pick up the slack and help you get the part you need for your application. Let's go to the shop. Okay, now we're over at the Markforged CFF machines. This is where things get interesting. So traditionally, FDM style printing has meant, hey, just a plastic part, and plastic parts can be weak. So enter Markforged. What's special about Markforged is Markforged has the ability to inlay each and every layer with a continuous strand of either carbon fiber, Kevlar, fiberglass, or a high strength, high temp fiberglass. So let's talk about the materials. So first is our base material, definitely the most famous material on the Markforged platform, and that's called Onyx. It's a nylon 6 filled with a chopped carbon fiber. So fundamentally your base material is a composite material, but then as we add fibers, we're going to change the characteristics of that material. So if you needed a part with ultra high strength, something equivalent to say a 6061 aluminum machine part, you would add carbon fiber into that part. If you needed a part that was going to take an impact or maybe get flexed repeatedly and you don't want that part to break, that's when you would put Kevlar into that part. Next would be fiberglass. Fiberglass is just an economical way to reinforce your material. So if you put fiberglass into your Onyx material, you're roughly 4.5 times stronger than standard ABS. And then we have a high strength, high temp fiberglass. This gets pretty interesting for a high strength part that's in a higher temperature environment. So that's going to get your part roughly to a heat deflection temperature of about 150 degrees C. So beyond our fiber strength parts, we also have some Onyx variants, so our base material variants. So we have a flame retardant material. We also have a variant of that flame retardant, so it's called FRA. That's geared specifically for aviation. It meets all your traceability standards that the FAA requires for manufacturing an aircraft. We have an ESD material, so it's just an ESD variant of Onyx for your electronic housings or anything like that. And then we as well have a food safe nylon. So we're seeing a lot of this on, say, food production lines, food conveyor lines, stuff like that. It's a pretty interesting material, and we have the ability to put fiber in all of those as well. So here's a part that has fiber. So you can see the fiber wrapped around the perimeter of this part. This is called concentric fiber. We also have the ability to do isotropic fiber. So all the space in between your concentric loops, we can do a zigzag pattern, and then we twist 45 degrees every layer. So as you can see, we can get some pretty high strength parts. So a part with carbon fiber, right, just has a minimal deflection. Carbon fiber, just really no deflection at all. On the Markforged platform, we also have some additional interesting features that you don't get anywhere else in the 3D printing world. The first is simulation. So in our software, we have the ability to assign those anchors and those loads and go in and verify your factor of safety. So what this is going to do is cut down on the number of iterations you need to get from point A to point B with your design. Another interesting feature is going to be inspection. So a lot of our Markforged machines have a laser micrometer built into the head. And what that allows us to do is scan the part as we're building the part, which enables an inspection report to be produced immediately when the part is finished printing. So this allows us to inspect uninspectable geometry in parts. So let's say you need a highly precise part. You don't have time to run it over to quality to get them to inspect it. Let us run that part. We can run the inspection report for it. You can run that over to quality, let them verify it, and off you go, you're ready. The one thing about Markforged that makes people stop and really think about 3D printed parts is we can produce a part as strong as 6061 T6 machined aluminum. So we're talking about an ultra high strength part at a fraction of the weight of your metal parts. So let's talk about real world applications of this platform. Easily the most popular is machine fixtures, work holding. You can replace those heavy jigs with extremely light, durable parts on your shop floor. Another fantastic application is inspection fixtures. So whether that be fixtures to hold up your very heavy part on an inspection table, parts going on a CMM, so maybe a nesting fixture, it's going to be extremely durable. Also, the onyx material will not scratch or mar your parts. So let's say you're inspecting a part with a mirror finish. You can put it up on a Markforged fixture part without concern that it's going to scratch or mar your mirror finished part. Another great application is end of arm tooling. So again, ultra strong parts, ultra light. What that means for end of arm is extended life in your robotic joints. Less weight just means less wear. You also have things like cantilevered brackets, support structures. Those parts, you just need those really high strength that you just wouldn't normally think a FDM part would hold. And then being able to replace parts with a very long lead time. So let's say we can print a part in just a couple of days as opposed to outsourcing that part that's going to take 6 weeks to get. You're going to save a considerable amount of money there. Let's talk about a couple of case studies that really drive this home. So a great real world example of what this technology can actually do is Wärtsilä. This company builds marine and energy systems, and they use Markforged to build a composite lifting tool for building cargo ship engines. That tool successfully lifted 960 kilos with a safety factor of 4. That's not a prototype. That's a production grade performance from a 3D printer. Another great example is the US Army also runs Markforged machines to produce personal protective equipment, window wiper brackets for military vehicles, tools, and low volume production components in the field. When the military trusts a technology for mission critical parts, that tells you something, right? Let's talk about when would you call us to produce a CFF part as opposed to something you would produce on your desktop in-house. If you need a part that has structural performance, So an ultra strong part that you know you're just not going to be able to get out of a PLA or an ABS. The bonus of that is we can also run simulation on that part to verify your loads and that your part is going to work in your specific application. The next application would be replacing metal parts with a composite part. Remember, weight always matters. So if we can produce a part for you that is equivalent strength to your metal part in a composite, it's always going to be advantageous. The next application would be if you need a part that is, say, V0 rated, which would be flame retardant, ESD safe for, say, your electronics components, or a part with just heat resistance built right in, here's your machine. So if you're in aerospace, medical, or defense, material certifications matter. We can get you material certifications for all of these materials off these machines. This is the latest and greatest machine from Markforged. This is the FX10. The significant accomplishment that Markforged has made with this machine is not only is this a composite machine, as you see right now, it's running a composite part. With a simple change of the print head, it's about a 15-minute changeover, we can be printing metal. So this machine can print both composite and metal, not at the same time, but this is replacing the Markforged Metal X. So with that said, let's jump into some metal applications and the Metal X that we have here. Let me break down metal for you. This is something that still today surprises people when I tell them about accessible metal. When I say accessible metal, this isn't $1 million machine. This isn't something that requires a dedicated operator, a clean room, or anything like that. This is an extremely safe technology. These are metal parts that you can produce directly on your shop floor today, or you can let us produce those parts for you. So Markforged has two metal platforms. The first and the original is the Markforged Metal X. This will run all of their metals currently. This machine is being replaced by this FX10. All of the metals aren't available on this platform today. By the end of 26, we expect to see all of the same metals from the Metal X over on the FX10. So the Markforged metal technology is referred to as bound powder extrusion. What does that mean? We're talking about a metal powder bound in a polymer matrix that is extruded through a heated nozzle, FDM style. So much like that desktop FDM printer that you have, just to the extreme, if that makes sense. The part that first comes off the printer is called a green part. This part has a scale factor built into it. Our software has a specialized algorithm that's going to add the proper amount of shrink to your specific geometry, and that part comes off of the machine, and that's called a green part. The next step in the process is a debinding. So we're going to put that part through a debinding process that is going to remove that binder in the material. And then the final step of the process is a sinter. So you're going to go through a full sinter cycle, and those times vary slightly just depending upon which material. So for materials today, we have 316L, 17.4, we have D2, H13, Inconel 625, and pure copper. The end result of your metal part is going to be a fully dense metal part with a layer resolution between 85 and 170 microns. Here's what makes this relevant to you as a customer. Traditional fabrication for a metal part, or even DMLS, is time-consuming and expensive. We're talking weeks of lead time and costs that can run into the thousands of dollars per part. In some cases, we can produce a part cheaper than those processes. Reach out to us, let us have a conversation, and we'll look at your specific application. A couple use cases that might help you. So we had a customer that needed tight clearance wrenches for an offshore rig with a 6-day lead time. Traditional machining would have taken 2 to 3 weeks, and even a laser powder bed fusion technology would have needed 10 days. We printed them in 3 days, saving the customer $25,000 in freight costs and preventing potentially millions in unplanned downtime. Another example is Shukla Medical, a surgical instrument manufacturer. They prototyped the initial designs on our composite machines and then moved to the Metal X for the final prototype. That final prototype goes directly into surgeons' hands for evaluation. It was made out of the same material as the production part, and it gave the surgeon full metal performance so that he could evaluate that part. That workflow saved them close to $10,000 a month in outsourced machining and prototyping costs. When to engage us to talk about a metal part? This is when you need a metal part in a matter of days or a week, as opposed to many weeks or months. Another application is going to be complex geometries, overhangs, lattices, things that are extremely difficult, if not impossible, with traditional CNC machining or manufacturing. Replacement parts for legacy equipment, this is actually a pretty good application. So pieces and parts that aren't being manufactured today, or you don't even have drawings for those parts, a lot of times those work really well on the Markforged platform. Another great application is to verify your design or your part in the actual material that you're going to machine it out of. So let's say you're about to commit to a pretty expensive machine run on, say, stainless steel parts. This would allow you to run a stainless steel part to verify that design out of that same material before you make that commitment to that costly machine run. So that's our metal technology. Let's move on over to the next technology. Okay, first let's talk about God, that's such a horrible word. First, let's talk about stereolithography. Say that 3 times fast. So we would use SLA when surface finish matters. The way SLA works is it's a laser or a light source curing a liquid photopolymer layer by layer. So when your parts off your FDM machine have layer lines and that's not a acceptable surface finish, then we would start talking about an SLA part. So the features of SLA parts are they have an ultra smooth surface finish, so your parts are going to come out of the machine basically ready to paint. You get a very high tolerancing, typically equivalent to that of a CNC machining a part, so plus or minus 0.2 millimeters as far as tolerancing is going to go. We achieve this with 25 micron layers, so we can run these machines all the way down to 25 micron layers, which is extremely small layer thickness. You're not going to get this on a FDM style printer. With SLA, we can also get uniform strength. So what I mean by that is you can get equivalent strength in all 3 axes, in the X, Y, and the Z, where comparatively to a FDM machine, you're only achieving real strength typically in the X and Y, and not in the Z because of your layer stacking. You have layer adhesion issues there. Probably one of the best features of SLA is the material versatility. Formlabs has been developing a resin library over many, many years. We've got close to 40 resins out there. The first is the Tough family of parts. So you have Tough 1500, Tough 2000, Tough 1000. They all have varying properties, but these are all parts that are going to be really tough. So if you had a part that say had a snap fit, or if you're working on an enclosure, and it just needed a all-around extremely durable part, these are the materials we'd use there. The next are high temp resins. So we got a resin that'll go up to 230 degrees C. What this does is open the door for tooling and molding applications. I've seen customers do small prototype molds, say like mud-based molds, just to prototype a part, low volume, get 20 or 30 shots off a part, just to prove out the concept before they go to hard tooling. The next is going to be a rigid 10K. This is going to be a glass-filled resin. This is extremely stiff, so if you need a part that's stable under load, this is the resin you're going to go with there. The next resins are going to be your flexible resin, so gaskets, grips, things like that. These are basically materials that you can't print on an FDM style machine. Not easily anyway. We've got some really neat elastomeric materials, all the way down to we actually do have a silicone. So then we have a castable wax. This is ideal for jewelers and engineers that are looking for small casting parts. And then we have a biomedical line. So this is going to be your dental pieces, surgical fixtures, stuff like that is all biomedical ready. So probably one of our more popular materials here is clear. So this part just came off the printer here. So you can see there's really not a lot of, maybe you can't see. There's not a lot of layer lines here. This part will get polished out and clear coated. This will be almost optically clear, except the customer doesn't actually want optically clear. So what we'll do is we'll polish this thing out, mask it off, and then we'll bead blast the face of this so we get a frosted look to it. Let's talk about situations in which you would call us to print a part as opposed to printing that part on your desktop FDM machine. So the first is if you have a customer review part. So if you're looking for essentially a part that's going to mimic the end product for a customer presentation, SLA is going to be definitely the way you want to go there. If you're prototyping a part with, say, like snap fit, living hinges, or things where your tolerances just really matter, right? So if we're trying to do a fit check, a fit and form check on a part, SLA is definitely the way to go. If you're looking for a part with uniform strength across the X, Y, and Z, remember I was saying we have uniform strength across all three axes. So if you're looking for a part like that, SLA is definitely where you're going. And then let's be honest, guys. You guys have been printing a part on your FDM machine long enough. You know what will work and what won't work, and what parts are just going to look terrible when it's done. If it's one of those parts, SLA is going to be your choice. Let us print that part for you. And then finally, I see this application a lot. So we have customers come to us and need multiple materials. So say, for example, a flexible part over the top of a rigid part, or a flexible part inserted into a rigid part. SLA is going to be the fastest way to accomplish that. So that's it for SLA. Let's move on to the next one. Okay, guys, now we're over at the SLS machines. So this is the Fuse series machines. SLS stands for Selective Laser Sintering. This is a technology I would recommend when we start talking about scalability. So taking your part from a single prototype into more of production, or let's call it maybe pre-production sometimes, right? So your higher volume of parts. So why would we recommend this for high volumes of parts? Well, to put it in simple terms, no support. There are no supports. So the way SLS works is it's an overhead laser in a bed of loose powder. So as your part builds up in the build chamber, it is surrounded by unsintered loose powder, and that supports your part as it builds from bottom to top. So what does that mean? You can build some extremely intricate geometries, lattices, undercuts that you can't build in other technologies. With the FDM, SLA is still going to produce supports that can be difficult to remove, and as well leave marks on your parts or pock marks, whatever technology you're using. So that's the biggest advantage of SLS. So a few other things that you can print on SLS that really add value are going to be interlocking assemblies, organic shapes. We do a lot of print in place for customers, and then high volume, right? So the SLS process, the overhead laser, is extremely fast. So we can print the entire volume in 24 hours. So perfect example. This is a full build volume. This was 293 unique parts that we built in 22 hours inside of the machine. So basically, you see all the different geometries, you see all the different parts inside of this. So what does that mean? You can pack hundreds of parts into this build volume, build them all at once. Build direction is inconsequential. So SLS materials. The material that we are running in the MLC production shop is nylon 12. We also have there's a nylon 12 glass filled, there's a nylon 11 carbon filled, TPU, and a polypropylene material available. Let's be clear, we run nylon 12 in our shop. It fits most of our customer needs because of its environmental stability and chemical resistance. The material is extremely strong, fits most of our customer applications, really. The nylon 12 is really, in the industry, is the go-to for functional parts. So just for reference, while we're here, as we build those parts, remember I said your part is suspended in loose powder. Once your part comes out of that powder, we have two other pieces of equipment that process your parts. This is called the fuse sift. That is going to sift out all of your loose powder and leave your finished part. That loose powder then gets recycled right back into the machine. So you get somewhere in the neighborhood of 95 and 100% material usage. So all your material recycles right back into the machine. That final piece of equipment over there is called the fuse blast. What that does is that does the final finish of your part. That's going to do all your fine feature cleaning, and as well kind of bring out the final texture of that part. We can also use that machine for texturing of other processes, and we'll get to that here in just a minute. So let's talk about features and reasons you'd come to us to print you an SLS part, right? Isotropic part strength. So unlike FDM, SLS has the same mechanical properties in every direction. So if you recall, this is similar to what we were saying in SLA. So you have the same strength in all three axes. It's going to be the same here in the SLS because that is laser-centered powder. What does that mean? It means they behave predictably in the real-world applications that you guys have. Volume production. This is where we see manufacturers really utilizing this technology. We often get orders of multiple hundreds of parts running across this machine. This is the fastest, most efficient way to do that. We also see injection molders kind of do a pre-run of parts on this. So what they'll do is essentially a production infill. So while they're waiting on their hard tooling from overseas or wherever that hard tooling may be coming, we can do short production runs to begin to fulfill the pipeline while they are ramping up with their injection mold. Also, guys, this technology is extremely accurate. What we see is plus or minus 0.5% in the XY, which is going to make it equivalent to CNC machining. The reasons you would come for an SLS part: a nice, durable part, high quantities, those 50, 100, 200, 300, they don't scare us. Parts where your geometry is just too complex for other print technologies, especially your desktop FDM, but even geometries that are too complex for SLA sometimes makes a lot of sense to go with the SLS. If you need a part with isotropic strength, so your strength in all three axes being equal, in-use consumer parts, either at low volume or high volume, those make a lot of sense for nylon 12 on an SLS machine. The reason for this is consistency, right? So your consistency from part to part is absolutely amazing. Your part's going to be exactly the same. Another great application that we see fairly often is a market test. So you have invented a product and you need to get a product out there to test the market. Let's see how the market reacts to this widget that you have built. Let us build you a volume of those so that you can go and test the market before you go to hard tooling that will allow you to kind of know where the market is on your particular product. Okay guys, with that, that's a wrap on SLS. One more stop. So let's talk about post-processing. So before I mentioned on SLS, we're media blasting your parts. Media blasting is an extremely critical part of that process to ensure that your production runs of multiple parts come out equal with very even surface finish, and that's done by media blasting in a tumbler. We can also do selective media blasting. So we do some selective media blasting. If you remember on SLA, I was explaining to you that light would be polished out and then we would frost the top surface of that particular lens. So what happens there is we polish the whole thing out and then we come back and we blast the top face of that particular part to give it that frosted look. Painting. So we can finish paint any of your parts. Just about every material you saw today can be painted or dyed in some way or another. Dyeing is a real popular thing on the SLS parts. Here's a part that has not been dyed and one that has been dyed. We do see that often a black part looks more professional than a part straight out of the SLS. So we do see a lot of customers request the parts be dyed. The other advantage to dyeing is that dye penetrates this part completely. So it's not like a paint where that finish can be scraped off of the part. The dye is through and through that particular part. So we have professional dye tanks where that we dye these parts in. As well as coating, we often suggest on a SLA part that you do a clear coat, and so we do offer that clear coat. The clear coat has a UV inhibitor in it, and what that does is stops that part from curing, since that is a UV cured resin. We also use that same clear coat on parts that people are going to put outside that are exposed to UV. It just adds another layer of durability to those parts. We also handle hardware, so whether that's hardware insertion or hardware assembly after the fact. We can put threaded inserts in a part. In Markforged parts, we can actually capture threaded inserts. We can capture magnets. Hardware is a pretty popular post-process for customers. Along with the hardware goes final assembly. So Quite often we'll get multiple parts to print that need to be assembled, whether they're mechanically fastened, glued together. We can handle that whole process. So the bottom line with MLC is the printed part is just the start of the process. The final assembly and post-processing round that completely out. You as the customer, we don't want you to get a part that requires a whole lot of homework. We'd like for you to get that functional part that you require for your application. So if you have a file sitting on your desktop today that you don't have the confidence that your desktop printer will build the perfect part, send that file over to us. Let us check it out. We're happy to have a conversation and tell you what technology we think fits that application the best. At the same time, we'll tell you what that part's going to cost and how quick we can get it to you. So guys, I'm Kyle Norman with MLC CAD Systems, signing off today. We hope to see you on the next one. Take care.